Welcome to Shule Light Digital Academy. In this session, we are going to learn how to use factorization method to find cube roots of numbers. We will be using live examples. Okay, in this session, we are going to use this question here, the question number 6, which says, use prime factor method to find the cube root of 3.375. So we are going to use that question to understand the concept of cube roots using factor method. So let me have the question written on my digital board. That is, we are being asked to use prime factor method to find the cube root, or maybe let me frame it to evaluate the cube root of this number here. The number we have been given as 3.375. Yeah. So we've been asked to use prime factor, which is not very far away from what we want to learn, to evaluate the cube root of 3.375. Yeah, to understand this, let me begin with something much easier. I'm going to pick a number like 216. Assuming that someone is asking you to find the cube root of 216 by factorization or using factor method. Let me just write it by factor. How would you go about that? To solve this, so we begin by expressing 216 as a product of its prime factors. What do I mean by that? Let me show you. We are going to take 216, then we look for the prime numbers. We begin by maybe the smallest one. So let me use 2 as the smallest prime number I have ever known, followed by 3, followed by 5, then the list goes on. Then we are going to take this 2. We ask ourselves, how many times does it go into 216? It goes there 108 times. Then we look for the prime number that is going to go into 108, and from my list I'm seeing 2, and 2 will be going there 54 times. Then the job continues. The smallest prime number that can go into 54 is 2, which goes there into 27. Then I think we are done with the 2. I can pick 3, and 3 will go there 9 times. 3 still will go there 3 times. And 3 will be going into 3 once. So I think you are seeing that we have found the numbers which when multiplied is going to give us 216. The numbers are 2 by 2 by 2 by 3 by 3 by 3. So we can group the similar one, or the like terms or the like numbers, can group them together. Then out of the 3 items forming a group, we are going to pick just an item. So out of the 3 items forming a group, we are going to pick one item from the group. One item from the group. Then when we multiply the item picked from each group, then we are going to get, for our case, it is going to be 2 by 3, which is going to give us 6. And obviously, the cube root of 216 is 6. Now, how do we use the same concept to evaluate this our number here? So let me clean this board. Yeah, the board is cleaned. Now, looking at this number here, that is 3.375. It is a bit difficult to express it as a product of its prime factors. So what do? We simply convert this number into a number which is going to be much easier working with. So I'm going to take 3.375. I feel when I write it as a fraction, and the fraction is going to be 3.375, and you can begin to think what is going to be here at the denominator. That is 1,000. Yeah, so the two numbers are the same. Now, working with this number is going to be much easier, especially when we are going to use the method. Which method? Factor method, to find what? To find its cube root. So I have two numbers right now forming a fraction. Which number? 3,375 and 1,000. So I'm going to separate them like this one here. I'm going to write the cube root of 3,375, that is the cube root, out of, let me use this white color here, the cube root of what? Of 1,000. So if I do this separately, my work is going to be much easier. Okay, let me begin from the numerator. Let me be consistent. Numerator, we are going to have, that is 3, which is the cube root of 375. So using our earlier concept, which concept? The concept which we've just learned from 216. So we are going to do the same thing. So this one, the best way we are going to work it out is what we have just done with 216. We are going to expressing 3,375 as a product of its prime factors. We're gonna have our tree diagram like this one here. So we are going to ask ourselves, which one is the smallest prime number that can go into 3,375? I feel that should be 3. So 3 is going to go there how many times? 1, 2, 5. Good. Let us give it another trial with 3. 3 is going to go there how many times? 3, 7, 5. I have a feeling that 3 can still go there. So 3 will be going there how many times? 3 will be going there once. Then that is 2. Good. Then 5. Yeah. Then 3 can never go into 125 completely. So we are going to go to the next prime number, which is 5, which I'm very sure it's going to go there. It goes there how many times? 25 times. Then 5 can still go there. 5 goes there how many times? 5 times. Then 5 can finally go into 5 how many times? Once. Then we'll be having them in groups of 3. So the first group is the group of 3's, which will give us 3, and the other group is going to be group of 5's, that is going to give us 5. So that if we take 3 and multiply by 5, that is 3. Let me be consistent. That is 3 multiplied by 5, we are going to obtain 15. So let me have 15 like this one there. Good. So from here we are seeing that the cube root of 3375, in fact it should be cube root at this particular point. Yeah, the cube root of 3375 is the same as 3 times 5, which is going to give us 15. Now, combining this with what we earlier had, what is it? This one here, the cube root of 1000, which is 10, then we are going to have our final answer as, let me rub this one down there. So we are going to have 15 out of 10, 15 out of 10. Where this one coming from? The upper part is coming from the cube root of 3375, which is giving us that 15, out of the cube root of 1000, which is giving us the 10 down there. So combining the two, we have the answer in decimal as 1.5. Therefore, we can summarize our work as the cube root of 3.375 is equal to 1.5 as our what? As our answer. Good.